Lewis. Chemir is a division of Evans Analytical Group, and today is our fourth go-to meeting presenting case studies involving plastics and polymers. This is a follow-up from a UL Prospector webinar we gave the end of April where we had 8 different abstracts we presented. And today is, again, the fourth case study that has a lot of the analytical detail generated and just more descriptions on the case study. Today's case study is the product contamination, which is essentially a packaging failure. And the case studies we presented with UL Prospector back at the end of April, these are the topics that we covered during that webinar. Lots of different topics dealing with plastics and polymers. And again, today's topic is a product contamination and a packaging failure. Again, actually one of my favorite case studies I put together a little while back. This is a real project we had at Chemir a couple years ago. And very intriguing, very challenging, very difficult project. But again, here's some of the details. And background, I'm going to go over the next 3 or 4 slides in about 15 seconds. Again, Chemir is who we are, a division of EAG. Complex problem solving is our main skill set. Lots of employees around the world. 3 pages here, just again showing analytical instruments that we have within EAG. So many different analytical techniques for separation, spectroscopy, elemental analysis. I mean, you can see all these different techniques here. And if you don't capture everything as I scroll through it so quickly now, this information will be on our website as well to take a look at. Again, right here is just page 3 of just different analytical techniques we have within EAG and many of these techniques here in St. Louis. The UL Prospector webinar dealt exclusively with projects involving plastics and polymers, and this page here is just showing the different types of polymers that we have deep expertise with analyzing, interpreting the data. Just again, very, very deep understanding of these materials, whether they're standalone resins, whether they're composites, specialty materials. Again, this is just some of our analytical expertise with all these different polymers. Now today's case study, again, this is the 4th one, dealing with a packaging failure, which led to a product contamination. But the contamination would not have occurred if the packaging didn't fail. And so we were presented, when a client contacted us, this is some of the background that was provided to us. And again, I always like to say, put yourself in the driver's seat. If you're me on the phone, talking to the client, getting this information, just think, where would you start with this type of analysis? How would you put together the technical project design? What analytical techniques might you use? So again, put yourself in the driver's seat and kind of think, how would you approach this type of investigation? Some of the background: a food distributor observed some discoloration of food packaged with a PVC film. And you can see some of the detail here. The same film had been used for years. The film where there was a discoloration was in this case, a specialty film for a very specific marketing campaign. And the discoloration only occurred when the food was packaged and in contact with the specialty film. Again, the same film had been used for years, but here's a slightly different color profile for this marketing campaign. And what drove the client to us initially was aesthetic issues. They couldn't sell a white-colored food product that had discoloration on it, splotchy discoloration. So aesthetics is pretty much what drove the client to talk to us. And our client, again, was talking to the supplier of the different materials of the PVC film, and the supplier was reluctant to provide formulation details, and that's not all uncommon. It's whoever makes the PVC film, it's their film, their material, they sell it to somebody, that somebody uses it. When a failure occurs, the supplier in this case was kind of reluctant to provide any details. So the technical request that came to Chemir and came to me was determine the root cause for the product discoloration. A main driver for that, they're trying to assess liability. So we have all this finished product that was packaged, but they're trying to assess liability. Who's to blame, essentially? The film supplier, the resin supplier, the converter, the packager, the food product. Again, who's responsible for this failure? And in the long run, financially liable for all this lost product. So while liability was a driver for this, just as important was investigating safety of the product. Was the product integrity compromised through this discoloration? So again, you want to know why it's occurring. You also want to make sure that there's no safety issue with the consumer. Someone that may have eaten some of this, maybe when there's the discoloration that really wasn't noted with the eye. So again, safety was a driver as well. So again, the technical request, trying to understand why this discoloration was occurring. Here's just some of the analytical techniques that we applied. And this project probably lasted 3 to 4 weeks, applying many different analytical techniques. Some techniques provided some results that were meaningful. Other techniques, simply don't provide anything that's meaningful. So very iterative approaches for these types of investigations. But again, this is just some of the techniques that we applied. And the slides I'm going to show you, again, this is just a summation of everything that worked, every technique that provided a clue to solving the problem. But again, very iterative, so you often hit dead ends where you really don't get a result that's meaningful. The technical design for this analysis was comparing some key materials that were involved in this packaging system and the food product. So looking at the packaging film, the standard film they'd been using for years, the specialty film that's for this marketing campaign where they saw the problem, and then looking at the food products itself, a control sample, clean regions of the food, discolored regions of the food. So comparative studies, looking for chemical markers that differentiated one material from another. And one of the techniques, this is HPLC analysis with a UV vis detector. And we performed an extraction of the film, of the actual colored specialty film. And we extracted the material and got this UV vis spectrum using HPLC. We also extracted some of the food that had the discoloration, analyzed it with the same technique, and lo and behold, we're getting the same profile, the same absorption, the lambda max of this bimodal distribution of the colored species. So right here is strong, compelling evidence that the color in the film, at least a color in the film, is migrating into the food. So again, the UV spectroscopy, UV vis confirms similar spectra between colorants in the specialty film and materials extracted from this colored food product. And the data did provide a general category of a food-grade colorant or a class of colorants to investigate. So that bimodal distribution, in the right hands, the right person interpreting the data, kind of narrows things down from hundreds or thousands of colorants to maybe several dozen. So it really kind of gave us a category of food-grade colorants to look at. And of course, with the packaging system, you're going to have food-grade materials used for the polymers, additives, colorants. Now here's another liquid chromatography technique using mass spectroscopy. And what we're showing here is a colorant isolated from the film and a colorant isolated from the food using organic solvent extractions. We again extracted the color from the food, ran the LC mass spec, got this chromatographic information here, which again shows similarities between color that was isolated from the film and from the food. So the retention times on the x-axis showing a common link. So once again, so now we've got two pieces of data that is showing similar information. Now when you go a little bit deeper with LC mass spec and you look at the mass spec fragmentation pattern, this is the lower information on the screen. So the colorant isolated from the film, here's the MS fragmentation of that colored molecule. As you kind of blow it apart and you're getting these different fragments, which is essentially a type of chemical fingerprint. So again, getting more and more information from this analysis. So here's the colorant isolated from the film. Again, here's the mass spec fragmentation pattern, a type of chemical fingerprint. And again, once again, in the right hands of someone that knows structural elucidation, can work with the general class of colorants we learned from the UV vis analysis. Putting these pieces together, we came up with a tentative structure of what's called scarlet B. Here's the colored molecule, food grade, used in PVC films, lots of different applications. So this is just one of our compounds that we suspected to be present. And remember, the supplier of the films was not providing information, so we didn't know what to look for. And so here's some more LC data with UV vis detection. And here we're comparing again. Here's the film extract, the UV-Vis spectrum from the film extract. From the food extract, you saw this before. And then we obtained a reference standard of scarlet B. And again, they pretty much are identical. So this is almost proof positive that scarlet B is the colored species in the PVC film, and that colored species is migrating into the food product. So some more LCMS data, again, the colorant isolated from the film, comparing it with the scarlet B reference standard. Again, a very good iterative approach. You're going from general information, coming up with some theories, some ideas. We obtain a reference standard, do parallel analyses, and now we're building a case with different analytical techniques showing that, sure enough, scarlet B compared against reference standard is the colored material used in the film. And again, we saw the color that's in the film is in the food product. So more LCMS data of the colorant isolated from the film and of the scarlet B reference standard, the mass spec, chemical fingerprints, essentially identical. So this is pretty much proof positive of the colorant that's used in at least one colorant used in the film that we found in the food. Some more LCMS data, again, just showing the film and food. And if you look at the color isolated from the food, how kind of noisy that baseline is, that's the bottom data set there. That noisy baseline is just reflective of such a low concentration of colored material that was in the food. Very difficult to isolate enough material to get a good signal. And this isn't even a good signal, but it's a sufficient signal. But again, that's why you get that very noisy baseline. It doesn't take much colored material to really give a pronounced visual appearance. Some more LCMS data, looking at molecular ions from the color isolated from the film, the color isolated from the food. And again, the food is on the bottom data set here, much weaker signal, again, because there's not much colored material that was present in the food. Certainly, you can see it visually, not much there to extract. So pretty much we confirmed with LC, UV-Vis, LC mass spec, we confirmed that the same organic colorant is in the film and in the discolored food product. And are we done? I mean, is the case solved? Well, the client wanted to go further. They wanted to know, why did this color migrate from the from the film to the food? And if you recall, in one of my first slides, the same PVC film formulation has been used for years, but this is just a different color package. So why, if you're using the same film, why are they having this issue now? So a second phase of this investigation was a chemical analysis of these same PVC films. The standard film formulation, the specialty film that was used where we saw this discoloration, and everything we did was essentially a deformulation study. Qualitative in nature, just looking to identify things, not necessarily determine concentration, but qualitative, comparing that standard film, the specialty film, multiple analytical techniques applied, again, analyzing the same PVC films. Well, when you analyze the same PVC films, here is one chemical fingerprint that we determine using an organic solvent extraction, using a derivatization technique. And if you look, the bottom chromatogram there, that's the control sample. That's the film they've been using for years. The top chromatogram, that's the specialty film, the suspect sample. It's supposed to be the same formulation. But you see towards the left, ESO is an epoxidized soybean oil. It's an additive commonly used in PVC films as a plasticizer, as a stabilizer. So this piece of data right here showed that these two PVC films are not the same. The supplier said they're the same. They're not the same. And here's the data that supported that. And so again, the same PVC film formulations? I think not. We identified significant levels of the epoxidized soybean oil in the specialty film that we didn't see in the standard film, the control. Again, as I mentioned, ESO is a common food grade stabilizer, process aid, and a different proprietary stabilizer system and process aid was identified in the standard film, but no ESO. So again, there was none of this epoxidized soybean oil in the control film. So our working theory was that the ESO, which is an oily material, solubilized the fat-soluble dye from the film, and the ESO and dye migrated from the film into the food product. So this was our working theory. We proposed a follow-up study to measure the ESO and dye migration rates, but this was enough information for our client to go back to the PVC film supplier, let them know what we saw, and that's when the PVC resin supplier confirmed, yep, we use a different formulation for your specialty film, and our earlier data showed that that was the root cause for this failure. So again, kind of a two-phase analysis here, which benefited our client and again helped assess liability, helped evaluate any kind of safety issues, which we did not see any safety issues. We're not really evaluating safety per se, but we saw that this food-grade colorant is the source of the discoloration, so it's not from some hydraulic fluid or some kind of external contamination. So again, the outcome is that we confirm the colorant in the film, we confirm the colorant migrates into the foam, into the food, we confirm the change of the PVC formulation, and all this information, again, allowed our client to assess liability for lost product. And back when we completed this, there was some pending litigation, again, to be financially liable for the lost product. So again, that's a lot of information I covered actually in 17 minutes instead of 15 minutes. A very interesting, very challenging failure investigation performed here at Chemir Analytical. If you do have any questions, again, it's a lot of data I just presented. If you do have any questions, feel free to email me, give me a call. And again, there's who I am, Christopher Andren. I'm involved with technical project design with Chemir. There's the phone number. There's my email address. You can feel free to give me a call, whether it's related to this case study or if you've got some kind of investigation on your own that you'd like to discuss. So I certainly appreciate your time, and again, feel free to call. Thank you.